oh no, I need a protein. The RNA takes the recipe, goes out, finds the factory. Someone remind me what the name of the factory is. The ribosomes. The ribosome goes, and the protein gets created and then gets sent to the FedEx store. The Golgi apparatus, Golgi decides where does it need to go, puts on the shipping label and sends it. The RNA is created here in the nucleoli. So that's all of the anatomy of our nucleus. Now, the nuclear envelope, or kind of the skin of the nucleus, this is what separates the nucleus from the rest of the cell. It's got these little holes, these little pores. And these little openings are so that RNA can get out. RNA is delivering the recipes and the instructions for the creation of different proteins. It's got to be able to get out of the nucleus and get to where the ribosomes are. So it's going to use these little openings to get out of the nucleus. That's it. That's all there is to that. That's all I got to say about that. I love that you have moose on your shirt. Camouflage. I like that. Moose is one of our national animals.
Have you ever eaten moose?
Yeah,
You can,
yeah.
but no. Ew.
I feel like a lot of animals just shouldn't eat.
You can, it's incredibly
It's
tough.
so good. It tastes like roast to me.
No, moose is very gamey. Very, very gamey.
Lamb tastes very good.
I
Have
hate
you ever
lamb.
had duck?
Duck is very greasy.
Oh my gosh. No, you gotta have someone that knows how to cook it.
Rabbit is very delicious, but it's also it's a very greasy meat.
Have you ever had guinea pig?
Have I ever had what?
Guinea pig.
No, but that sounds delicious.
Usually in South America, it's like a specific breed that makes them like this big.
Yeah, no, I haven't had that. I've eaten kangaroo. I've eaten buffalo. What other?
Where have you gone to eat kangaroo?
I had a good friend of mine go to Australia and bring me back some kangaroo jerky. It's like beef jerky over there.
They eat a lot of kangaroo.
They eat a ton
Every day.
because
They
kangaroo for them is beef for us. So,
But we like cows, but they don't like kangaroos.
well,
That's why they eat them.
they breed kangaroos specifically for eating them. Like, I have tried alligator. It was a little fishy. I'm not a big seafood fan. I don't eat seafood pretty much at all. I have tried squirrel, rabbit.
Rabbit's delicious.
Rabbit is very, very delicious, but again, it's very greasy. I'm a very heavily tactile person.
Have you had dove?
I've not had dove, but I have had pigeon. I've had a nice pigeon pie.
That is really good.
I've had frog legs.
Frog legs, never had that. That's disgusting.
It's so good though.
Nuggets.
Tastes like chicken.
Apparently everything tastes like chicken.
No. Part of
No,
that.
for real. It tastes like chicken with what is that? Have you ever had Slappy Mama? It's the seasoning.
Oh, yeah, I have that.
Or Zatarain's.
Cajun seasoning.
Yeah.
No. Alright, so the nucleoplasm is just the stuff, the jelly stuff that fills up the nucleus, and then we have all of our chromatin, which is the strands of DNA floating around in it. So this structure here is what we've pulled out of here. So this is the yolk of our egg of the cell. Chromatin is our DNA, and when we super coil it and we make a replication of it, the chromatin now forms a chromosome. That's how you can remember. Chromosome is made of this super highly coiled DNA that is replicated. That's it. That's all I need you to know about that. We're going to talk about how does DNA replicate itself and how does that fit into the whole scheme of things with mitosis. I know I keep saying the dreaded M word. You're all having PTSD. Is somebody knocking at my door?
No, they just put it off the wall, the door.
Oh, okay. It doesn't affect my life any, so.
Oh, no, that's on the door.
Okay, you guys are not gonna pay attention to
Scare
me
her.
until you find out.
Scare her.
They are not gonna pay attention to me until I tell them what you were doing. I'm putting up a sign that says. Are you happy now? All right. That is the ending of our amazing cells. So let's, oh, I should probably share this. I'm going to go through just very quickly and touch base with our lectures that we've done the last couple of days, just to make sure that there are no concepts that we need to clear up. I really need to get a mouse or a clicker. Oh, I lost it. There it is. All right. So going back to the beginning, we know that the term for a cell that has no nucleus is, yep, hooked on phonics, prokaryote. And the term for a cell that does have a nucleus, eukaryote. The eukaryote, we know size-wise, much more complex, but much bigger. Needed a lot more energy. And so the prokaryote, we believe, was incorporated into the complex cell as what structure? The mitochondria. Because the mitochondria has its own DNA, but it's not contained within a nucleus. Do cells need to have a nucleus? No, they do not. In fact, we talked yesterday about red blood cells and how that would be counterintuitive. If you filled up part of your transport with a nucleus, you don't now have the same amount of space for a gas exchange. You're going to have way more trucks to deliver the same amount of oxygen, and our bodies just simply couldn't have that many trucks on the road. So that's why it's important that in that case, we don't have a nucleus.
Did you say that eukaryotes have, like the prokaryote is the mitochondria in the eukaryote?
Yeah, so that's the big theory. So here I've got the picture of our prokaryote. Here I've got a picture of the eukaryote. There's our nucleus. And the size here looks the same, but what we're actually looking at is this prokaryote is right here. And so because it contains its own DNA, that's why we believe it was during the evolution that this particular primitive cell was incorporated into the complex cell to provide energy.
Yeah.
Nah, it does not have the little tail things. It moves around like a big brown slug. That's the movement that it has, and it moves around using part of the cytoskeleton. In fact, it uses the largest component of the cytoskeleton, which would be the largest component of the cytoskeleton. Shall I just tell you?
Yes.
Microtubule.
That was never gonna come out.
That was never going to come out of your face.
I almost said not a question.
No. Okay, so now we know we gotta bone up on our cytoskeleton. Remember we had the microtubule made of tubulin, and it forms tubes. Biggest part of the cytoskeleton. It's how these organelles move around the cell. If you think about the inside of the cell like space, you've ever seen, it's actually pretty fun, but in my mind, absolutely terrifying video. There's this astronaut on the International Space Station and he got stuck. So he's right in the center of the room and all of his handholds are out of reach. And he's just suspended there. And he's like, trying to move himself like in his swimming, but there's no way to move. That's kind of how our organelles are suspended inside our cell. And so these microtubules form these little roads, these little highways that they can now move around and anchor themselves to. That's our microtubule. All right, before we do that, let's talk about the cell membrane. We got our hydrophilic, hydrophobic, know those. Hydrophilic are on the heads.
Like water.
They love water. Hydrophobic, tails. They are repelled. They are disgusted by water. This fluid mosaic, this lipid bilayer, has a ton of stuff wedged into it. It's very, very complex. We've got proteins, carbohydrates, cholesterol, all of these things that do one of two things. Well, technically one of three things. Stabilize the cell membrane, allow the cell membrane to change shape, help stuff move through. All of these next things that we talked about that are embedded in the cell membrane are there to do one of those three things. So we have these proteins. There's some proteins in there that are embedded. We had our integral proteins. These proteins are, let me minimize you guys. The integral proteins are creating channels through specific things can pass. We have our selective channels. Selective means what to you? VIP. Only a certain person can get in through these selective channels. You have to have the VIP card to get to pass the line. If you've never done VIP, I highly recommend it. You'll never go back. Back pre-COVID, my significant other and I used to go to the Comic Palooza. Anyone ever gone to the Comic Palooza? No?
But I've heard about him.
It's here. It's like the Houston version of Comic-Con.
Yeah, no.
Would you dress up us?
Once with theater, but.
Oh, it's so much fun. We collect our photographs with celebrities. So that's kind of our thing, is we go to these Comic-Cons.
So you don't cosplay?
We do. We usually do the whole weekend, Friday through Sunday, and we'll cosplay on one day and not cosplay on the other. And the non-cosplay is the day that we get our pictures taken.
What do you all cosplay?
Well, I want my picture taken with me, not the character I'm playing.
But it's more funny, like when you show like.
We did cosplay for one of them one year when we saw Bill Paxton.
Like, what do you all cosplay? Like, y'all do, like,
Depends.
couple
That year
ones,
we
or do
did.
y'all each
That
do
year
one?
we did the original Avengers, which is the British, like Emma Peel. You don't know who they are. It doesn't matter. 2 years we went as Harley Quinn and Joker. I've worked for 7 months on that costume. I made my own hammer. It was like this big around.
Gotta show us the costume.
I will show you. Well, I will at some point show you a picture of us as Harley Quinn and Joker. Right? Yes. Well, yeah, that's what we do. We like to go. My whole point is VIP is the way to go. Pass up the line. Now, pores allow general admission. Now, remember, you still got to have a ticket, but they're much less selective as to the molecules they're letting through. So there's our peripheral proteins. Remember, peripheral out to the sides. And these are going to be important in changing the cell's shape. Changing the cell's shape. I'm circling this. Do you think that might be on the test? Yep, probably. Every cell has a unique coding. This is its identifier. This is how the body knows who belongs and who does not, and who should we start launching an attack against. It's called the glycocalyx, and it is cellular recognition. That's it. Is everybody okay so far? Is everybody on the bus? Anything you need me to clarify more? Bueno. So we talked about the glycocalyx. We've got two families, the CAM, which helps our cells stick and move over each other, but also helps to sound the alarm when we need backup. And then we have these membrane receptors, which are also involved in our signaling and cell recognition. Cilia, everyone show me cilia, the movement of cilia. That's our sea anemone. It's kind of like crowd surfing. Flagella. Like a whip-like motion that causes forward propulsion. In mammals, there is only one cell that is flagella, sperm. But there are many cells that have cilia. The cells in your sinuses, the cells in your trachea, the cells in your lungs all have cilia. The cells in your ovaries to very gently crowd surf the egg into its implantation in the uterus. All right. Let me just quickly go over, make sure everybody's okay. Stop.
I'm not going very far. I'm in a rush. I'm a little uncomfortable. Sometimes I just forget.
What the
There's
heck?
no such thing.
That's not even a podcast I was listening to. That was not open on my phone.
Did you turn your flashlight on yesterday? Did yesterday your flashlight, you got out your phone and then the flashlight turned on? Did you do that? Or is your phone just as that?
I think I'm just gonna, like, that's not even a pod. Oh God, don't call the ambulance. That, seriously, that was not even a podcast that I had queued up.
This is when you get a new phone.
No.
Nah.
Nah.
Expensive.
That was crazy. All right, let's talk about our cytoskeleton. Just make sure everybody's okay with this. There's the three. I'm going to tell you right now, you need to know the three components of the cytoskeleton. I am going to have questions on your test in direct reference to these. One possible question could be, which of the following is the largest component to the cytoskeleton? Thank you. Which of the following is the most permanent and rigid component of the cytoskeleton? The intermediate fibers. Which of the following is the least permanent and aids in changing a cell's shape? Microfilaments. We had two other terms for our intermediate fibers depending on what kind of cells they were in. Somebody tell me the term we used for an intermediate fiber in an epithelial cell. Say it?
Monofilament?
Yeah, the tonofilaments. How about an intermediate fiber in a neural cell? Neurofilament, yeah. All right, so we all know mitochondria is the powerhouse of the cell. Tell me the area of the mitochondria where ATP and cellular respiration occurs. Say it?
Christine?
The cristae. The cristae, the little folds right there. Nicely done. How does the mitochondria multiply? Fission. There's the cristae. Ribosomes, these are the little factories of the cell. They're the most numerous organelle, and they're found most commonly here on this extension of the nucleus, which is called what? The rough ER. What does ER stand for? Endoplasmic reticulum. What organelle of the cell is involved with detoxification? We talked about specifically with alcoholism. The smooth. Nice, the smooth endoplasmic reticulum. Detoxification. Good. This is the organelle that helps to destroy free radicals by converting them into peroxide. There you go, peroxisomes. Once the free radical has been converted to a peroxisome, what is it now further converted into? Water. Which is the organelle that organizes spindle fibers to help pull chromosomes apart? The centriole. Some of you have slightly confused looks on your faces. Is everybody okay? So here we have, there's the extension, a rough and the smooth. The rough is the assembly of our ribosomes. Smooth is detoxification. Oh, the Golgi. That's the shipping center, isn't it? That's where we create that protein and we take it to the Golgi, and the Golgi repackages it, stamps it for delivery, and sends it out. So here we've got a little transport vesicle, and it goes to the Golgi. The Golgi goes bippity boppity boop, repackages, and then sends this particular shipment shooting out into space. Lysosome is known as the suicide cell. This is what causes autolysis. Tell me what autolysis refers to. The breakdown of itself. So the lysosome has these kind of digestive enzymes, and they will bind with other vesicles, pour themselves into it, and break down foreign invaders. But when the cell is getting older and getting ready to be replaced, it creates more and more lysosomes that all eventually just kind of go, ah, and release all of their contents into the cell, and it breaks down the cell. Peroxisomes, we just went over that. Removes free radicals by turning them into hydrogen peroxide. Inclusions are just a big void. Some of them are used to transport. Some of them are used to trap debris. Some of them are used to trap foreign invaders. And depending on how big they are, that will determine their name. A vacuole, a vesicle. These are just both types of inclusions, which is just a void. Centrioles, we just talked about that. And then we just finished our nucleus today. Any comments, questions, concerns?
Go back to Chris saying.
I will go back to Christe. So a lot of the questions that I've asked you today are questions that are directly off of the test for tomorrow. Like true or false, all cells have to have a nucleus. False. Remind me which part of the cytoskeleton is the most permanent and rigid? The intermediate fibers. Where in the mitochondria is ATP production and cellular respiration? That's Chris Day, Hooked on Phonics, guys, it's right there. Hooked on Phonics worked for me.
What does the Christe do?
It is the site of ATP production. ATP is adenosine triphosphate, which is the energy. And so the Christe is where we have the energy being produced and the gas is being exchanged, the oxygen and the carbon dioxide.
What about the ribosomes?
Ribosomes are the factory of the cell. They read the instruction manual that is provided to them by the RNA, and they create the proteins that they've been asked to create.
I agree with on the chat, it says, I don't know how to eat anything besides chicken.
Yeah, I don't eat chicken either. Every once in a while I have burger, but.
Yeah, I predominantly eat beef and chicken. I mean, it's not like I'm out every day, you know, hunting down squirrel. It was an opportunity, I tried it once. I eat a lot of big salad. Oh,
So good, your brisket's good. And then the dog.
oh no. Oh, that's terrible. So yeah, I've been